All right, so we are recording right now, and we're going to start a new chapter. Okay, parallel lines and transversals. We have talked about parallel lines. Somebody tell me what they know about parallel lines. They never intersect each other. Very good. Okay, so watch. If I put two lines like this, I copied and pasted. So if I put two lines like this, and remember, lines have what on the ends? Arrows. So if I have two lines, and they never intersect. If they're in the same plane, if we want to get really particular, they have to be in the same plane and never intersect each other. Then we call them parallel lines. What about two lines that are not in the same plane and don't intersect? We have a word for that. We don't use it very often, remember? Skew lines, okay? But these are not skew because they're in the same plane and they never intersect each other, so these are parallel lines. Let me just, when do I want to do that? I think we talked about this before. I don't have this on my notes, but I think it's probably important to talk about. So if, like right now, if you had a piece of paper, right, and I typed this and I put two lines on there and I just handed it to you, could you tell me that those lines are parallel to each other?
Yeah.
Why?
They're on the plane.
Okay.
They have two lines and they're not touching.
Okay. With that said, look at this and look at this. They don't touch.
No.
Are they parallel?
No, because if you keep running up the lines, they'll intersect each other.
Okay. How do you know they're not going to intersect each other?
Because they're going this way.
Yeah. What if I did this? And you didn't know I did this. Oops. See what I did? It's just barely slanted. But you couldn't tell, right? What if it's slanted like 1 degree and there's no way in the world you could look at that piece of paper and tell? Would they eventually intersect each other? Yeah, they would, okay? How do you know it's not slanted 1 degree? Because you can't tell by looking at it. Okay, there's got to be a little thing. Good, I like that. Oops, didn't want that. Want this. Okay, there's got to be a little thing. Here's a little thing. I think we talked about this. Remember, if you put it, and it's not a dash, because that would mean that they were congruent to each other. Okay, it would be segments congruent. But if you had this, if you put an arrow here and an arrow here somewhere in between, not the ends, okay, but in between here like this, what does that tell you about those two lines? That they're parallel. That's right. Okay, so you have to know whether they're parallel or not. Now we're going to do some things in this lesson. They're going to show you that things are parallel with not knowing other stuff. Anyway, that makes no sense. It'll make sense once I finish doing this. All right, let's do this. Let's go back to white. Let's move up. I'm going to introduce a new word to you, a word that we're going to use quite a bit, especially in this chapter. Probably more in this chapter than anything else, but it will pop up from time to time. So let's say, I'll tell you what. I'm gonna purposely make it look like it's not parallel. They don't look parallel at all, do they? No, because if that kept on going, this kept on going, yeah, they would eventually touch each other. So I just kind of made it so it doesn't look like they're parallel. Made it kind of obvious. And you could put arrows on the ends if you wanted to. Let's do that. Just to be a little picky. All right, there. And let's put an arrow on this line. What about this red line? Not red lion, but this red line right there. Is that parallel to this line? How do you know it's not parallel? Because they intersect each other, okay? Let's not say cross. Let's say they do what? Intersect, okay? And what about this line right here? It intersects there. So that red line is definitely not parallel to those two white lines. Agreed? But we have a special name for this. Since they do intersect, since that red line intersects those two white lines, it has a special name, okay? And we call it a transversal. Transversal. Okay? So a transversal is a line, okay, that intersects at least two other lines. All right? If I just had one line and it intersects, we wouldn't call it a transversal. But if it intersects two or more lines, then we would call it a transversal. You could have the lines going all kinds of different ways. You could have 3 lines, and that red one would still be the transversal. So watch, let's draw a line like this. That red line's still a transversal. Why? Because it intersects all 3 of those lines. Where does it intersect? Right here, right here, and right here, okay? So transversal is a pretty important word. All right. Let's talk about one thing, then we'll talk about another. So let's do this. What if I had two lines? This really doesn't have anything to do with transversal, but it does have to do with intersecting lines. And that's what we're going to talk about. So I got two lines that intersect each other. And they actually form some angles in here, don't they? Let's label these. We'll call that angle right there angle 1. We'll call this 2. We'll call this 3. We'll call this 4. I'm not going to put any letters on here. I could, I guess, if I wanted to. I'll just make it super easy. So I'm talking about this angle 1, this angle 2, angle 3, and angle 4. You with me so far? All right. There's a relationship between two pairs of these angles. Zanaya, do you remember this? You probably hit this all the time last year, didn't you? Do you remember what it's called? Look at 1 and 2. I'll tell you right now what the relationships are. Look at 1 and 2. There's other relationships too, but I'm looking for one particular. When I say relationship, what in the world am I talking about? How they relate to each other. Okay, there's something in common with both of these. Smart? Okay, both lines intersect right here. Okay, that's true. The lines intersect, but they form these 4 angles. I want to look at the angles. What's true about the angles? Look at angle 1 as 2. That's exactly right. Okay, so angle 1 and angle 2 are exactly equal in measure. Okay, they have the same measure. So angle 1 looks more than 90, doesn't it? Let's say, I don't know, let's say it's 100 degrees. I'm just making that up. I don't know if it is, but let's say it's 100 degrees. All right, so what would angle 2 be equal to? 100 degrees. Good. Everybody got that? Now we have a name for that, but I'm going to show you something else. So what do you think might be true about 3 and 4? That they're equal to each other. So instead of putting one arc, because look, angle 1 is definitely not equal to angle 3. Would you agree? Because angle 1 is obtuse, angle 3 is acute, so they're not equal to each other. So what am I going to do to show the difference? Put 2 arcs. Good. Put 2 arcs here, and then put 2 arcs there. So the ones with 1 arc are equal to each other, and the ones with what? 2 arcs are equal to each other. Make sense, right? Yeah, pretty easy. Now, we do have a name for those. So what I could do is I could say that angle 1 is equal to angle 2. And what else is true? Angle 3, what? Is equal to angle 4. Okay? So those are going to be equal. And we give it a name, and we call them vertical angles. So anytime the angles are across from each other, if I have 2 lines that intersect, it doesn't matter. Like, I didn't draw those 2 lines like perfectly so that 1 and 2 would equal each other. I could have drawn the 2 lines like this. And still, these angles that are opposite each other, or what do we call them? We don't call them opposite angles. What do we call them? Vertical angles. All right, so vertical angles. So the vertical angles are always what? Equal to each other. And in geometry, a lot of times we use the word congruent. I could say that as well. My guess is in the book, they probably say vertical angles are congruent. Do you remember what congruent symbol looks like? Yeah, it's the equals with a little squiggly, okay? Technically, if I said angle 1 is equal to angle 2, it means the measure of angle 1 is equal to the measure of angle 2. So that means if this is 100 degrees, this is 100 degrees. Now, without me telling you anything else, how many degrees is angle 3 or 4? 50? 360? Don't think about the whole circle. Look at angle 1 and 3. There's a relationship between 1 and 3. They're not equal to each other. It's 180. That's it. You got it, okay? You see that? She said it's 180. What's 180?
Degrees.
Yeah, but what is 180 degrees? From here to here. What do we call that? It is an angle, but it's a straight line, so we call it we've discussed this, a straight angle. It's a straight angle. How many degrees is a straight angle? 180 degrees, okay? See that red one right there? It's a straight line. Now, straight line's 180 degrees, right? You ever hear somebody, like preachers say this all the time. They'll say, you're walking towards sin. You're walking towards the devil. But God wants you to turn around how many degrees? What does he say? 180 degrees, which means you're going the complete opposite direction, right? So instead of going to evil, you're going to good. Instead of going to the devil, you're going to God. Everybody with me on that? All right, there's your, what do they call that? Your spiritual something. They tell us every day we should have some kind of biblical integration. That's what they call it. So there it is. There's my biblical integration for today. 180 degrees. All right, so if this is 100 degrees, then what's left over? It's what? You already said it. Go ahead. It's 80 degrees, right? So that's 80 degrees. So check this out. What's angle 4? Okay, why is it 80? Because it's a vertical angle, right? So you know 3 and 4 are equal to each other, so that has to be 80. Agreed? So if this is 100, if I just knew one of those angles, I could find the other 3. All right? If I just knew that was 100 degrees and that was it, I knew that was 80, I know that's 100, and I know that one's 80. All right? So that's kind of cool, right? They just give you one thing, and you can figure out a lot of the other things. All right? Same thing here. Again, it doesn't matter what angle I make those lines. All right? This is still, right? This one is still equal to this one. And what else? That one is equal to that one. Okay, why? Because vertical angles are always equal or congruent. All right? Some teachers have a fit if you don't say congruent. I'm fine for the most part just saying equals, okay? But there are some teachers that really have a fit if you don't say congruent.
Shouldn't you put 3 of those like lines or whatever for the 180 angles?
Nah, because you kind of just see it. You know that's a straight line.
If I put 1 line or like 3 or whatever?
No, I wouldn't put 3 on that. No, because you know it's a straight line. So I just put that just to get everybody to see that line. All right, that's all. The only reason I did that. Now, the whole reason we did that is so we can do this next thing. All right, you're going to see that a lot, vertical angles. So always look for that. Anytime 2 lines intersect, those vertical angles are always going to be equal to each other. Okay, anytime 2 lines intersect each other. All right. Now, here's what we're really here to learn today is this. We're going to take that transversal and we're going to do more stuff with the transversal. All right, let me change the color of it. I'll go red again since I went red the last time. I'm just going to be lazy and not put my arrows at the ends. Everybody okay with that? Nobody cares if I put the arrows, do you? But you know they're lines, so technically they do keep on going forever. But, you know, it's just a waste of time. So I'm going to list a bunch of, I'll do some different color, go blue. I'm going to list a bunch of angles, all right? So call this one, oh, I thought I was going blue. What happened? Put it up there. Okay, there we go. Now it's blue. Get rid of this. Let's try this one more time. All right, here we go. So we're going to call this 1, 2, 3, 4, 5, 6, 7, 8. All right. So we're going to have these special, probably made this too big. I didn't give myself much room to write, but that's okay. I will do this. Let's just scooch this over a little bit. Scooch this to there. There we go. All right, what I'm going to do is there are some relationships between these angles. I'm going to give you the names of the relationships, all right? And then after I do that, then I'm going to do something else. I'll show you. So I want you to see these angles. The first ones are called corresponding angles. I'm going to put the angle symbol. Is that all right? Angles, instead of just write it out the whole time? Okay. Now, you do see some relationships that you already know. What do you know about 1 and 6? And that means they're what? If they're vertical, they're equal to each other. Name me some other vertical angles, like up here in this group. 2 and 5, good. What about in this group down here? 4 and 7 and 3 and 8, good. All right, so right off the bat, you know some angles that are equal to each other. Agreed? Now these, we're not going to say whether they're equal or not. All we're going to do is just give the names of them. All right, that's all we're learning right now. And then as soon as we do that, then we're going to do something with parallel lines. You'll see how it all comes together. All right. So I just want you to list the corresponding angles. Remember how I said you have a group of 4 up here and a group of 4 down here? All right. What I want to see is which ones correspond to each other. For instance, angle 1, if I was to describe angle 1 to you, I would say it's the angle in the top left corner. Does that make sense? So where would angle 5 be? In the what? Top right. 2 would be bottom left. 6 would be bottom right. Everybody got it? So I want to see which ones of these correspond or match up with these down here. That's not us. Okay? So 1 and what? 3 match up with each other. Keep going. 5n, 7, 2n, 6n. They're corresponding angles. Okay? Now, I haven't said anything whether they're equal to each other, not equal, if they're whatever, but they're the corresponding angles. So I'm going to write angle 1. I'll put a comma. And angle, what was that, 3?
Yeah.
All right, and what's the other one? Let's go angle 2. Angle 2 and angle 4, what? Angle 5 and angle 7, yep. And then angle 6 and angle 8, good. So they are all the sets of corresponding angles. That's easy, isn't it? Yeah, because correspond, it's a word that we kind of understand. Just means they match up with each other. All right, here's one that's kind of weird. And this one is called alternate interior. That's a word we did last chapter, isn't it? Interior angles. Alternate interior angles. Well, first of all, look at my 2 white lines. Do you see the white lines? And the red line is called the what? Transversal. Good. So we got 2 lines cut by, and that's what we say. When they intersect, we say that it's cut by. All right? Because it's going right through here. It's slashing through this line, slashing through this line. So it's cut by, or 2 lines cut by transversal. Okay? The alternate interior angles. When they say interior, they're talking about in between the 2 white lines. In between the 2 lines they give you. So list all the interior angles here. 2, 3, 6, and 7. Okay? Everybody with me? So what would 1, 5, 4, and 8 be? Exterior angles. Okay? Everybody with me on that? Now what about the word alternate? So interior, I'm only looking at 2, 6, 3, and 7. The alternate means the ones that are completely opposite each other. All right? So what's completely opposite of angle 2? Well, it's on the other side of the transversal, but what's even more? 7 is. You see that? See how they're completely opposite? This is at the top left, right, of these 4 right here, right? It says the top left, this is the bottom right. All right, so they're completely opposite. They're on the other side of the transversal, and it's connected to the other line. Everybody see that? So the word alternate just means from here, not just straight across. That's something else. We're going to talk about that in a minute. But from here to here. So let's list. There's only 2 pair of alternate interior angles. It would be angle 2 and what else? Angle 7. What's my other pair of alternate interior angles? You got it. Angle 6 and angle 3. Good. Sounds like she's taken geometry before. Sinai, did you ace geometry when you took it? You did it? Oh, you did. Okay. I figured you did. All right, so the alternate interior angles, those are them. All right? Now, this shouldn't be that hard. I'm going to shorten alternate. Is that all right? ALT period. And I'll shorten interior. All right, and then I'll put angles. Oops. I didn't mean interior. What did I mean? Exterior, right. So just EXT. So let's list the alternate exterior angles. So which ones are the exteriors? 1, 5, 4, and 8. So which ones are alternate exteriors? So like angle 1 is an exterior angle. Which one is alternate to it? It's 8 all the way down here. See how it's up at the top left and this is at the bottom right? Yep, so angle 1 and angle 8. What are your other pair? Angle 5 and angle 4. Good. So angle 5 and angle 4. So they're my alternate exterior angles. We got one more set. Tell you what, you already wrote the corresponding down, didn't you?
Yeah.
So I'll just, let's do this. That, let's hit that, let's hit this. There we go. Let's just scoot that up out of the way. All right, we got one other set, and these are called consecutive. Now, this is the word they use, and some books use this, but I taught out of another book, and I like their phrase so much better. They call it consecutive interior angles. And I'm still going to write it down because that's what you'll see in the book. Or, this is the way I like it said, it means the same group of angles. Okay, no, you writing this down? Same side interior angles. It means the same thing, all right? But I like the word same side interior angles because it kind of describes it a little bit better, I think. All right? So let's take a look. Again, we're talking about the interior angles. So what group of angles are we just dealing with right now? 2, 6, yeah, you can go 3. 2, 3, 6, and 7. Okay? Those are my interior angles. Which ones are on the same side of the transversal? 2 and 3 are on the same side. And what else? 6 and 7 are on the same side. Everybody see that? All right, so let's jot those down. So angle 2 and angle 3. And I'll put an and right there. I probably should have put it right there. And what else? 2 and 3 and angle 6 and angle 7. So those are my consecutive interior angles. All right. You might see that word on the quiz and test. Okay. But I used to teach out of a book that called them same side interior angles. I like that a little bit better. Consecutive means just one after another. So what's on the same side of the transversal? It goes 6, then 7, right? 2, then 3. That's why they call them consecutive interior angles. Everybody good with that? All right. So now we're getting to it. Wait, so
does it matter which angle you put first?
No, it doesn't make any difference. Nope. All right, so we know the names of these things. Now what we're going to do, we're going to get a little bit more specific, okay? We are not just, these 2 lines right here, these are any 2 lines, right? But I'm going to get more specific. What kind of lines do you think we're going to talk about now? It's in the title of the lesson. Parallel lines, that's right. So these are not parallel, correct? So they don't have to be parallel to name them. But for what we're going to do right now, they have to be parallel. All right, so I got a line. Let's make it a little smaller so give myself room to write some things. Yeah, let's drop that down a little bit. All right, so there's my 2 lines. Again, they should have arrows on them, but it's just a waste of time right now. And I'm going to draw a transversal. And I'm going to do this. I'm going to put a little arrow here and a little arrow there. What does those 2 arrows mean on this? It means they're parallel to each other. Okay? So, can I say, just by looking at that right there in front of you, without me saying anything else in the world, can you say those 2 lines are parallel to each other? Yes. Why? Because they got the arrows. That means they told you they are parallel to each other. Okay? Everybody with me? All right. And we got a transversal. Let's just move this over a little bit. There you go. And let's put some numbers in here. I'm going to change the numbers just a little bit. I'll still use 1 through 8, but I'll just put them in a different spot. So 1, 2, 3, 4. I'm going to go 5, 6, 7, and 8. All right, now, these are all theorems except for the first one. The first one is a postulate. Did we ever talk about that? The difference between a postulate and a theorem? Okay, let's talk about it now. So a postulate, and you'll see these words, they kind of look the same, to tell you the truth. If you look at this postulate and then you look at the next theorem, you're like, well, what's the difference? Well, postulate does not have to be proven, okay? You just accept it as fact. So a postulate, you just accept it as fact. You don't have to prove it. Okay, they tell you this is a postulate, you're like, well, tell me why. Well, it's just true. I'm like, okay, got it. All right? But you also have another word called a theorem. A theorem looks very similar to a postulate. If you just read them, you probably wouldn't know the difference between one or the other. Okay? But a theorem, I'll say it can be proven. It can be proven. And all the theorems that we're going to talk about at some point or another have been proven. Sometimes they're going to ask you to prove these theorems. When I came back to teaching math after doing the media arts thing, I decided I would not hit proofs very heavy at all. Zanai, did you guys do proofs in your other class? Yeah. I decided not to do the proofs. Not because they're not important, because I do think they can really be important. We are going to prove some things, but we're not going to prove it like they kind of do in the book. We'll do it a little bit different way. But that'll make it a little easier on you guys. You should be very, very grateful. Would you agree, Zion? Be very, very grateful that I'm not going to hit proofs in here, all right? Because it's kind of tough. I liked it. I enjoyed it. I had a lot of students that enjoyed proving things, but I'm not going to do it in here. It's time consuming, and there's just so much I want to get to. If I take too much time on proofs, I just won't get to a lot of other things, all right? But I just wanted to show you those words because that's what we're going to see right here. So let me do this real quick because I am running quickly out of time, but we can do this pretty fast. If you have two parallel lines, remember I'm going to go in a little different order. I'm going to talk about, oh no, we did this in this order. We did corresponding first, didn't we? This is our first postulate. It's called, I'll shorten it. It's called the corresponding angle postulate. That's supposed to be an O. Postulates. All right. So this is the corresponding angle postulate. The corresponding angle postulate says, if you have two parallel lines cut by a transversal, do we have that situation here? Yeah. Do we have two parallel lines? Yep, Samara, you with me? Come on, snap out of it. If I got two parallel lines cut by a transversal, then all the stuff I'm going to show you is true. Instead of just listing the corresponding angles, I'm going to tell you something about them. So remember what we said about angle 1? Whoops, I shouldn't have done that yet. I gave it away. Angle 1 is corresponding to what? Angle 5 in this situation, right? I changed the numbers a little bit, all right? So 1 and 5 are corresponding angles. The postulate says that the corresponding angles are actually equal to each other, okay? They are exactly the same. And it should make sense. Look, this line right here, this white line is angled the same as this white line, isn't it? Okay? And you got this line right here, and it's angled the same way with both of these. So look, this angle right here should be exactly the same as this angle right here. Would you agree with that? Yeah, and it's true. So what can I write? Angle 1 is, now I can say it's equal to. What we did earlier, we just listed them. That's all we did. But now I can say that angle 1 is equal to what? Angle 5. I'm going to go through this quick because I got less than 5 minutes, okay? So let's do the rest. Angle 2 equals what? Angle 6, because of corresponding angles. Angle 3 equals angle 7. And angle 4 equals what? Angle 8, okay? That's a postulate. It's just accepted as fact. We don't have to prove it. I got a couple more. Okay, let's do the alternate interior. Alternate interior angle. This is called a theorem this time because we can prove it. I'm not going to right now because of time, but I could give you like a little mini proof of it, but I'm not going to right now. Let's list the alternate interior angles. Angle 3, and what else? What's the alternate interior angle with 3? Not 5, 6, because it's completely opposite. See, 3 and 6 are completely opposite. All right, but we use the word alternate. So 3 and 6 are alternate interior. This theorem says that the alternate interior angles are equal to each other as well. All right, so that's nice. So 3 and 6 are exactly the same. What else? Angle 4, what do you think that's equal to? Angle 5, good. All right. You also have an alternate exterior angle theorem. I'll just shorten theorem. I'm running really short on time. Let's list those. Angle 1 is equal to angle what? 8. I'll answer for you. And angle 2 is equal to angle 7. Very good. All right, we got one more set. See if I can squeeze this in and still see the picture. Now we have consecutive, I'll just shorten it, consecutive interior angle theorem. Now check this out. Everything's been equal, right? And it seems like we would say angle 4, what's the consecutive interior angle with angle 4? Angle 6 is, right? But look at angle 4 and look at angle 6. Is there any way in the world they're equal to each other? There's not. What kind of angle is angle 4? No, it's not straight. Angle 4, this angle right there. It's obtuse. It's bigger than 90. Look at angle 6. That's acute, isn't it? All right. Is there any way that they're going to equal each other? Nope. But they are. Here it is. The consecutive interior angle theorem says that those two angles are supplementary. What does that mean? Did I spell it right? Supplementary. There we go. Is that they add up to 180. So angle 4 plus what? Angle 6. They're not equal to each other, but they do what? They add up to 180 degrees. Give me the other consecutive interior angles. Yeah, angle 3 plus angle 5. What do? They also add up to 180 degrees. Now look, we didn't have enough time to do an example, but there is an example. They give you a perpendicular transversal theorem. If you understood what we just did right there, that should make complete sense to you. But they do give you an example too. We just did not have enough time to do example 2. But here's what I want you to do. Okay, I want you to I don't know, go over, we'll say. Go over it. All right? Read it. Don't leave. Have a seat. Go over it. All right? I want you to read it and try it. They give you these, they give you the steps. Are you listening? They give you the steps in the book. You guys are honors class. You should be able to do this. I probably wouldn't do this for a CP class, but honors class, you should be able to go over it. I just didn't have enough time to hit it. All right? We had a lot of things at the beginning I had to do. So here's your homework. It's section 3.1, obviously, and it's page, what is it, 111? It's on the paper I gave you, but I'm just putting it up here. And it's 1 to 21, but, I don't know if I wrote this on here, did I? Did I write omit? Look at the paper I gave you, the lesson plan. Did I write this?
Yeah. No,
Omit 6 and 7. Did I just put 1 to 21?
Yeah.
All right, so omit, what does that mean to omit? Don't do it. Leave it out, okay? That's your assignment right there. You don't have to do 6 and 7. Everybody good? All right.